So a warm welcome, and this is about C++, the course that we deal in the third semester of Electronics and Communication Engineering. So before entering into the course, the background of the courses, the background of the course will be dealt in consideration with our Electronics and Communication Engineering department, and what is the use of C++ in our department, and how the C++ can be viewed in our own perspective. So this is the main motto behind the course. So C++ language, before entering into C++ language, let me know in our own terms. We normally speak in terms of hardware and software. We remember that we differentiate in terms of hardware and software. So hardware, it deals with some electronic gadgets or devices. I take it as devices. Software, here we deal with certain higher level tools. We either in terms in understandability, I can able to take that it is a certain high level programs that is either a Java, something else. So what is the difference between this hardware and the software? You may remember that our own department is in specialization. We can able to put our persons in hardware companies or in a software companies. So our persons will be equipped in either in hardware or in software or in both. There are certain students who have been good enough in hardware component and also in software component. They can able to write good codes, and they can able to understand the fundamentals of our own area. And so the company profile for our department, we can able to rely on these both arenas. Hardware, the concept of electronics and communication is involved. We can able to put our persons in electronics arena, or we can able to put our persons in our communication arena. Normally we will go in the area of either in the formation, in design, either in testing, or else we can able to go for the service oriented arenas. Once again, when we speak about software, there is a combinations of product and services. Product is we develop our own codes. And services, when the codes have been generated and they are need to be serviced periodically for the consumers. So these are the arenas behind where our electronics and communication persons are being placed. Okay, let me speak in terms of these hardware and what is the relation with hardware and software. So we have devices. Hope when you learn in your the lower semester, you remember that you have learned with the semiconductor physics, where you learned with the basic p-n junction diode, Zener diode, these are. And these components involve voltage and current. And we normally call those devices as analog devices, analog electronic devices. And there are certain devices we call as digital devices. We call it as digital devices, which can able to understand 1 and 0. So I can able to say that the devices can able to understand 1 and 0. One, in different angle we can able to say. One, the availability of data. 0, non-availability of data. 1, the availability of voltage. 0, the non-availability of the required voltage. 1, we call it as it is available. 0, it is non-available. These are the basic information. Hope you are we will learn the same in your semesters. Analog in our semester you will be learning EC1, and here we will be learning with the digital paper is there. So analog device and digital device, and you may able to experience the difference between these analog device and digital device in the forthcoming when these courses moving on. You can able to understand what is electronic circuits 1 and what is the digital. and how the electronic circuits one works, and what is in the terms of voltage and current, and here what is the information as relevant with 1 and 0. So you can able to understand when these courses are going on, how they are being spelled and how it has been viewed. So C++ language, we use the combination in connection with the digital circuits. So a digital circuit can able to read some information or can able to store some information as 1 and 0. So a digital data with relation with 1 and 0, there are the subject digital electronic circuits will be going as like this. The 1 and 0 we take in terms of the digital circuit has been activated. So 1, it is used to activate the digital circuit, 0 is used to deactivate the digital circuit. The second perspective of the digital devices will go as like that. It can able to store information. That if it is 1, the information is being stored, and if it is 0, the information is not being stored. And the third perspective of a digital circuit is I can able to read the information from the digital device. If the digital device can able to be read, it is having the information as either as 1, and if the information is not being available, then it has been read as 0. So first it has been viewed in terms of operating. The 1 is used to operate a digital circuit, 0 is used to deactivate a digital circuit. Second, it can able to store, and third, it can able to read. So when the information read and write combination is being taken into picture, the digital component will be termed as an architecture. There are many devices. Hope you will learn in your third semester. And so a digital circuit can be made to add certain digits, can able to made to subtract certain digits, and so when it is being done with a combination of multiple devices and automated, then it forms an architecture, and we call this architecture in the formation of a microprocessor. So microprocessor, I can able to go far, I can able to make the device to add certain numbers and subtract certain numbers, and certain decisions are being done, and this is being used as a microprocessor. And the microprocessor need to be coded. Suppose I want to add two numbers. Example, I take two variables, A is equivalent to 5, B is equivalent to 6. And I need another variable C that is equivalent to A plus B, and this can be involved in your architecture and a microprocessor, and it can be coded and it can be done. And so A is being given with 5 and B is being given with 6, and C can able to go with A plus B, and this I call it as a code. And so this code is going to drive a hardware component, and this hardware component will produce the result that has been expected by the person. We normally you call this code as machine level code. Machine level code, or we call this a mnemonics. We call it as mnemonics, and I hope you will learn once again in the upper semester. So a digital is a component, a group of component clubbed together to form an architecture, and it is being coded. I take an example. If I need a TV, I go to the shop and purchase a TV and bring it to my hall, and the hall is having a TV, a sofa set, and some decorative materials, and these all put together we can say that the furniture is available in the hall. And so every component to component is called as an individual component. It has its own individuality, and when it has been clubbed, I am been calling as the infrastructure that has been available in my hall. And so the same add a circuit, a subtractor circuit, multiplier circuit, all are clubbed together to form an architecture, and this architecture need to be coded. So so need to be coded. And this is I'm writing a code for a digital component and understandability of 1 and 0, and so I call this as a machine level code, or this is a mnemonics. Okay, so this mnemonics will bring in picture. Suppose if I write a code, you may not remember what is a microprocessor, though I am writing some sample code for here. It is A is equivalent to 5, B is equivalent to 6, and C is equivalent to A plus B. So I am taking one register and I am moving 0, 5 to it, and I am taking a register B and I am moving 6 to it. I am once again assuming that an operation has been done, and I can able to take as like this: C is equivalent to A plus B, or I can able to take as A is equal to A plus B. This is also possible, and this is also possible. C is a third variable, and A is an available variable that I can able to as A plus B. So I can able to take A is equivalent to A plus B. This I can able to say, and the variable 11 is been stored, and it is OA. Servo B, because it is an hexadecimal value that is been stored. So this can be done as a code, and the information is been available as like this. It is B is 1011. It's an availability of hexadecimal number in the base of 2. So this is the information that has been stored in your memory, that after adding 5 plus 6. So these are hexadecimal number. So remember that this information 5 has been given as a binary notation. It is 0 0 0 or 0 1 0 1, once again 0 0 0 0 1 1 0. So this is the information given, and this is an information given to A, and this is the information given to B in terms of 1 and 0, and the added information is in terms of 1 and 0. Remember, this is an 8-bit value. If the bit goes on increases, normally when you go to any one of the shop, normally you go to any one of the digital transaction, there we call it a random number is generated. Predominantly I hope it is a 16-digit number, or it is a 20-digit number, and it is hard to remember, and it has been generated for every time to time. Every time to time. So it is hard to generate. Let me have yet another example. I remember a mobile number of 10 digit. It may be my father or mother, and beyond this I can't able to remember the 10-digit number of my friend or a group of friends, because it's a 10-digit number that is hard to remember. The combinations of 0 to 9, it has been arranged in multiple fashions to form a 10-digit number that is hard to remember. So if a group of bits is being given out by a hardware component, then it is a human perspectability is it is hard to remember, it is hard to interpret, and so days passed by, we gone with inventing a compiler and assembler. Normally first is an assembler, another is a compiler. So the motto of the assembler is my information that I have been giving to the machine has been understandable for me, and if it has been going to the machine, the information need to be transcoded as 1 and 0, and it has to be understandable by the machine. So normally this is an assembler, and this assembler normally it is going with conversion with mnemonics. Mnemonics, that is a machine level code to the 1 and 0. This is a binary pattern. So machine level code example, microprocessor, I am written some scrap code here, isn't it? I can able to have a microprocessor code as like this: move immediate A with 05, move immediate B with 06. You may learn this in your forthcoming semester, but a scrap code, that is what is meant by mnemonics, and add B, a scrap code. So I can able to understand that move immediate A means I am just moving A, the content A register with 05, and I am been moving B with 06. So this is the statement that I mean understandable by me, and that is an understandability statement of mine. But when it is going to a machine, this move immediate will have hexadecimal value, let it be 3e. So 3e notate move immediate A, and it is 05. So this first hexadecimal value shows that it is a command that I have to move accumulator, that is an A register with 05. So the interpretability, that is I am writing the code as like this, the machine need to be converted as 3e, 05. So the conversion of move immediate A to 3e will be done by the assembler. That we call it as a mnemonics to a binary pattern, and a compiler is the user level language. If I am writing certain code in Java, and that need to be understandable by the machine either in the formation of 1 and 0. So the higher level language to a machine level language, that is a code, that is 1 and 0, is normally called as a compiler. Hope you understand. Once again, we look into the pattern. We said about what is a hardware and a software, what is a device, what is an analog device, and what is a digital device. So the relation with this C++ language is with the digital component. Digital component I said about as a single component, a group of components, an architecture, and how to write code in it. And so I am taking a template of A, B, and C. And if I write an automated code in machine language, this will be the pattern that has been followed, and this is the code that is written in a microprocessor. Normally if it is 05, it is once again the pattern is 4 zeros, 0, 1, 0, 1, 0, 1. So when it is been added, normally the pattern will rotate as like this, 4 zeros, 1, 0, 1, 1. So this can't be remembered by a human person if the bits goes on increases, and that cannot be remembered, and that cannot be interpreted certain thing. So normally assembler and a compiler has been introduced. As assembler motto of the assembler is to convert a mnemonics to a binary pattern. Compiler is to convert the user level language. It is maybe written in either in a Java language or else any other languages, and to a binary level language. So this is the motto of the compiler. Let me continue in the next video. Thank you.